Data Stewardship. Moss is now recording the meeting. Thank you, Moss. So a little bit about me. I've done QA for about 20 years. I started doing QA just out of college down in the little old town of Eugene, Oregon. I started actually working at a video game company down there called Dynamics. You may know them from such video games as Mech Warrior or Starseeds Tribes. I did not work on any of those. I worked on their biggest flop. It was like a $3 million video game. It didn't go anywhere. But it was still a lot of great learning experience, and I got the bug of doing software testing. Since then, I've worked up in worked around. I worked up in Portland. I worked at Intel for a little while. I've worked back down to Eugene for a textbook company that was writing little programs to do software, to do like problems in an automated like calculus textbook. So calculus became useful, which I never thought would happen. Then I drifted around. I ended up here working for some automotive stuff, and finally landed at NWA, where I met Heather. And we work at educational software, giving assessments to students. And there's a ton of data that we generate, a ton of data that we accept from our partners, a ton of data that we do all sorts of things with. Otherwise, I love camping. I love going to live music. I love traveling. I'm going to London next in a couple of weeks for a good spell, so that's going to be a lot of fun. Gaming, and occasionally I try and make wood into something that's not wood and is actually functional. One day I hope to make it beautiful. So cast your mind. It's a crisp, drizzly February morning, and my senior vice president of the product development department where I work comes to me and Heather and so a couple other people and says, "Hey, we've got a data quality problem. I need you guys to take the lead to solve it. I just need you to fix data quality for the whole company. Just figure it out." I thought, great. How hard could that be? In fact, what more do you want? He's like, I don't care. You just figure out data quality. What's the cause of our data quality problems? How do we know we have a data quality problem? So Heather and I sat around and we started thinking about it on ourselves and together, and we're like, this can go pretty deep. We don't really know much about data quality other than that intrinsic field of, well, we know it works. We know when people complain about it, but we can't just measure the old qualiton scale and figure out like, oh, this data is 42.5 qualitons. You're fine. Qualitons don't exist. So I thought, let me Google that for you. So I started Googling data quality and immediately found there are a bajillion data quality tools that will tell that all usually expensive, usually don't seem to solve your data quality problem. They just seem to set up your data. They most of them are like Informatica, Talend, Boomi. A lot of the ones that come up seem to be very much like, we will be your data tool to move data around, and you could maybe use us to measure quality, but we're not actually going to tell you why or how. It's a very complicated system. Academic Works came up. The Stanford data governance model was one of the highlights, and that in fact has been adopted by part of our company as the long-term governance around data, and I will talk about that a little more later. And then also the big thing was like, there is no single data quality. Data quality is a very rich, deep subject with 100 dimensions to it. So without what I was really looking for was, okay, there's all this talk about data quality. How do we actually measure something? I don't care about the theory. I don't care about the practice. I care about what is a thing I can actually put a measurement to. And I was struggling to dig into to find that. So then I went to the next thing. When Google fails, go to Wikipedia. And Wikipedia said, data quality refers to the state of qualitative or quantitative pieces of information. Data is generally considered high quality if it's fit for its intended operations or decision-making or planning. And also that it's really contentious. No one can really decide what data quality is. So great. I was like, great. Well, at least I'm at the textbook definition of data quality. I don't know what I'm doing and I don't know what it is. And I can only tell you when it's fit and it works. Well, one of the things I picked up off of there, so yeah, I really started digging into what can we actually measure. What does fit for purpose mean? And I, one of the things Heather and I did that I really helped us keep on focus for the whole project was we dug into what were our defects. What were people actually reporting as data defects? What was the impact to the company? Where did those defects really creep into the system, and how did they get there? And we kind of boiled it down to like, well, data quality is fit for purpose when data is high quality, nobody tells you. When data is low quality, people come out of the woodworks to tell you your data is crappy. And being a company that we accept a lot of data from our partners, we reflect that data back to them. We show them data in a variety of forms, and that data is expected to match up. We get a lot of feedback when we have poor quality data. So we kind of knew like, okay, well, here's where poor quality data is coming in. How is that working? How do we find that before it hits our partners, our customers? We call our customers partners. It's very cute. And then what is it? How do you really get to that standard of meeting or exceeding your customer expectations? And really what we came down to was quality requires comparison. You have to compare the data you have with some other data set to analyze its quality at all. So data quality is a comparison of the actual state of a data set to a desired state. We kind of hung our hat and said, this is our theory of data quality and how we're going to start measuring it. Yeah. That comes into play. In fact, reality often is part of how you define your ideal state. But a lot of data, of course, has non-real components to it.
Can you repeat what the question
identifiers
was?
that you slap onto the data tables? Those aren't real. Those are, exist in that data plane. So using
Nick,
we dug around and I decided like there seems like there's two kinds, like looking at all the literature and looking at what we ourselves have done. There's two real different kinds of data quality comparisons you're doing. The first is what I call the intrinsic data quality of a data set. And that's comparing a data set basically to an idealized version, like to kind of the reality that it's supposed to represent, and seeing how you can dig into that. And a little bit of just terminology I wanted to throw in here. I tried to come up with a technology agnostic way to talking about data, because if you're using Mongo or Postgres or MySQL or SQL Server or any of the various flavors, everybody has their own terms for what everything is. Is it a table? Is it a document? Is it whatever? So I use what Postgres would call a database, a big data store, or even a single table. I call that a data store. A field, of course, is any particular field or a column or a named piece of data that is replicated across that table. A record is a single row or a single part of the document. And datum would be one particular tiny little piece of data, because data is the plural of datum. So going back, data fidelity, intrinsic data quality, comparing that data with itself. The other one we did is data, I call data fidelity, which is actually where most of our problems were, which was when data is copied from one data set to another data set, you want to make sure that data, or one data store to another data store, you want to make sure that data has been copied with high fidelity, that all the important aspects of that data are actually in the target data set, and you haven't lost any, transformed any, blown them up when they get over to the target database. Intrinsic data quality. This is the one a lot of the stuff online focuses on. The idea that you can take a data set by itself and just kind of you know what right is. You know what good looks like. Are the integers all integers? The fields are all the data you want to have in there. Do you have a state for every address? Do you have a house number for every address? Do you have a last name for every person in your database? That kind of thing, where there's a lot of data forms that culturally we accept. Here's what the data should look like, and how well do you match that? So that's kind of the idealized form of all the data. And the dimensions that are usually talked about and that we kind of started adopting are timeliness. How quickly is that? How up to date is that data? How much does that data actually reflect reality in the database? Especially, how does it reflect the changes we know are continuing to accrue on that data as time goes on? Completeness. For a given record, do we have all the pieces of data that we should have for that concept? The house number for a street name, or the state for the street for an address. First and last names. All the credit card information. Do we have the expiration date on the credit card? All that kind of thing. Data quality. You can look at data sets and kind of start picking out the holes in the data where there's nulls or empty fields, and understand, like, if there's too many of those, you get a feel that the data quality has been impacted. Uniqueness, obviously a very important field for anybody that is doing that is working with databases, in that they are entirely driven, or at least old school databases are entirely driven by unique fields. And fields that primarily to identify for us primary identifiers, so you can know this data goes to this conceptual person or car or whatever object it's supposed to reflect in reality, and track that down. There's in a lot of old school databases, we work with a lot of Postgres. Uniqueness is not a concern, because we just make the field unique in the database. Like, the data will refuse to accept anything non-unique in the database. More modern databases that we're shifting to, stuff in Snowflake, stuff in the Amazon, but that is not a thing the database keeps track of. That is on the consumer to track that data, and it is something that can easily drift away from the ideal of, hey, everything gets its own unique identifier. We're great. Instead, you end up with something closer to our ugly reality. Social security numbers are not unique. People share those sometimes. It's really ugly. Aptronymity was a word Heather found. I'm going to give her full credit for this. And it was, does the name of the data field actually reflect what the data is supposed to represent? Like, a problem we found when really digging into data quality was our names have changed over the past decade or so that we've worked there for concepts that our company completely invents and writes and builds data for. We didn't change the names in the databases. We didn't even change the whole names of the database. We have a whole database that's named after a thing it used to do that it no longer does. No, we haven't changed the name of the database, because that'd be really hard. But that in particular instance is just fun. So far, I haven't seen it cause any problems, but that is the kind of thing that's like where data quality sneak in. There's been other parts in our field, looking at the defects we had, looking at how what people reported as problems is like, oh, well, I see why people made that problem. They thought this field that was named X meant this. Well, it no longer means that. Now it means something completely different. We just never changed the names in the databases. So that snuck in. That's not one I found that I actually have ever seen really talked about online, but it's one I really found that like drove defects, is just having misnamed fields and having your data the names of your data not match up to what the data actually represents. Plus, who doesn't love a good Greek word? Data accuracy. Data accuracy is one I don't want to include in this set, but I have to, because you're dead right. Most of what we want, the highest level of concern for data is how much does this data actually reflect reality? And the reason that's kind of that's what accuracy really talks about. And the reason I don't want to include accuracy in the data set is because I don't really have a good way to measure it. Because I can't just go get out my reality measuring stick and go, all right, reality, how many qualitons are you? Okay, cool. I'm gonna just compare that to the data set and I'm good. That doesn't work. The best we've come up with so far for measuring accuracy is to do laborious things like capture all of the data inputs that we get to our system, and then at some point compare, like, do those inputs still match what's actually in the database? And we haven't really done that. Orderliness, lastly, is data often comes with structures, implicit structures to it. How well is the data ordered within those structures? Whether that's a complex or simple database structure that you've put together to express some business idea, or just a common idea like addresses or names. There's often structure that spans across data fields and data records, and there is a way to check, like, does the data in the database match these structures that we expect, and that's orderliness. Now on to data fidelity. Actually, you know what? I'm gonna skip past this. I'm gonna go to this definition. I'll come back to data fidelity. So how do we measure some of those intrinsic data set things? Usually we crawl through the database and do things like find a percentage of records or fields that are missing data. So for measuring, what did I call it? Consistency? Completeness, yeah. For measuring completeness, we want to know how complete data is. So you go through every record in the database or every field in the data set, data store, and you count, like, how many, what percentage of those fields are empty or nulls. And that kind of gives you a baseline of, like, where you're at. And then you can continually make that measure. And if that measure seems way too high, go in and start cleaning up your data. If it seems all right, just keep measuring it and see, like, as new data comes in, does that percentage rise or fall?
Question. Does null in this instance mean that it designed the database that shouldn't have nulls, or that?
Yes. Depending on what your data is and what it's designed to express as a real world object, null might be a completely legitimate field. There's times where null is there. It's like, what's the color of a bald man's hair? Well, they don't have any. So null for hair color seems completely legitimate. Oh yeah, sorry. The question was, how does null factor into, like, a completeness? Like, do you,
if null is a valid field?
Yeah, is null a valid field? And sometimes yes. And that's why you can't just go 100% this data. There must be something in every column in this database, or it's bad quality. Because there are often legitimate reasons why a null is a field. Whether it's to express a certain, character of the data, where hey, null means, we know if this field is null, then this particular data item doesn't have these characteristics, and it's a different kind, and we're kind of lumping a bunch of different things together in the same table because it makes sense. So yeah, you can't just go like, oh, it's not 100%, we got a data quality problem. That's why you kind of have to level a baseline, look at your data and go like, hey, about 80% of the time we've got data in this field, but 20% of the time it's null for one reason or another. Great. And then measure that again over time and see, like, are we sticking to that 80-20 rule, or that we've discovered, or is it shifting? Is, like, if it starts going down, it's like, well, now only 70% of the data is populated. What's going on? Like, did our business shift? Are we just getting different data in, or do we have a data quality issue and somebody's not, some data is not being propagated? Completeness is great for that. The percentage of your data is like, how many of these have the same value? That one probably should be 100. See, that's a good example. Like, that one probably should be 100%. Like, if you've identified a field as unique and you have non-unique values in there, you got a data quality problem. And then also the other way we thought to look at it was a comparison of the data fields with data dictionary definitions. What is the data dictionary supposed to, what does the data dictionary say this data should be? What are the, whether that's just the, except, you know, what's the data type and what's the, like the precision of that data should be, or, you know, is it something like an enum where it's only going to have, or like even states. So if it's United States and somebody puts in Alberta, you got a problem unless you extend it to Canada. Running through that kind of thing. And that's where data stewardship starts to come in as the people that start doing and what the business terms that you're meaning to express. Question.
According to the point of reality, you are part of a government benefit program. You very much need to make sure that people applying for the benefits are real human beings. They're not dead, and they live in your state. I'm not really sure these are really being visualized across your dimensions.
There's a lot of data dimensions. That's, I think we'll get into that when we get into data fidelity, which is the next thing. And because, yeah, eventually when you have to start tying all the data together and figuring out like how does it match reality, there's no good solution to that. How would you, let's say you worked for the government and you had to make sure person X.
Yeah, we have procedures for that.
What's the procedure?
We have an expert. There are certain tests you can perform to assure, usually involve the use of social security, FBI, and other data.
Yeah, so you've got to go look up your data you got to cross check your data in other databases to see what's the status.
In time, data may get corrupted, but what happened is data can be faked.
Data can be faked. Data, the world moves on and the data doesn't. Like those are all great scenarios. I haven't actually seriously thought about how you would run through higher level data. What's that? No. Fake the world moves on and data doesn't. those are two separate statements. Honestly, that's what we deal with a lot in my company is just our data is static, especially in our testing infrastructure. The data is static and the world keeps moving on.
Commenting on the fact that you are making certain assumptions on your definition of data quality.
I am I'm making certain assumptions about data quality. I am definitely making definite data assumptions about data quality. I'm trying to focus on what you can actually measure for data quality within a given data set that you have. If you need, like, there's higher level dimensions of data quality that go into that really dig into like what is the data, what does the data mean, what is the use for the data, how did you get the data, where's the data going to be going to, and I will get to those because I think you're dead on. Those are the higher level data quality issues that really drive defects.
When you have a name, is that a real person? Is that person live? Is that a higher dimension?
It's a higher dimension because if your data quality is such that somebody types in a name and the wrong name shows up in the database where you pull a report to see who applied for Social Security benefits this month, then this person doesn't exist. Their name doesn't exist at all. Like they don't get benefits when it was a data quality issue of you're just not transferring data between two data stores, right? Both. Most low level data quality problems are caused by bugs in software. And you kind of have to get over that hurdle of having like high quality data that at least you can believe the data that you got into the system is the data you are seeing 3 steps down the line after it's gone through a bunch of transformations and data. then you can start looking at your higher level data quality issues of, is this person alive? Is this a real address? Is this a real car that they've reported, or are they just trying to scam the system? Yeah, and data accuracy is really hard to measure from a QA standpoint, because of ultimately you have to go find some other data source or reality to say, hey, is this real or not? And then you have to trust them. Like, why is the FBI correct when they say somebody's dead?
So let's say you work for a multinational company. You have Chinese colleagues. They use English names, but then if they go back to the Chinese side, the real name isn't the English one. It's
right.
Aviation. Or English database might not have any link.
Yeah.
I mean, their legal name might be.
Yeah, it might be totally different. How do you connect that together? You either trace the data back to trying to figure out, like, hey, when did Bob Wang log into the system? Who is Bob Wang? Oh, turns out Bob is not his real name. Yeah. Oh yeah. So the question was, what if you're working for given a multinational scenario where somebody in China may enter an English sounding name into an English database, but their actual name is, it's Chinese. It's represented by characters that might not even be represented in your database. How do you track that down? And again, this is the high level problem that we really want to get to is, how do you match your data with reality? Yeah, but then you need another database that could have poor data quality. Yeah. Yeah. Yeah, let me go through this. Data fidelity, comparing two data sets together. It's there's a couple of valid dimensions here. Consistency, how well the data is matched between the transformations. Are you keeping the precision on the numbers correct? Is the calculation spitting out a right number? Set completeness, huge. We ran into a ton of problems with this, where you would, for one reason or other, we said business wise, hey, we only want to copy like certain records from this database over to this other database, or data store over to this other data store. And then almost always we found out, like, oh, we actually need a bunch more of those data. And so we would either intentionally be missing some, or we would accidentally be missing some, like if they got lost in the pipelines, due to high bandwidth issues or something like that. So set completeness was huge for our data. Transformational integrity, making sure everything's, if a transformation occurs on the data, it is occurring correctly. If there's a complicated calculation, that calculation is being done right. You usually need to pull in a third, like a independent calculation on that to validate that given the source data, the right data is coming up in the target database. And then exactness, when copying between two data stores, make sure the data means the same thing, you haven't changed the name of the fields or changed the name of the fields so much so that now the data seems like it's representing something different than what it actually used to in the source database. Best way to check your data fidelity is kind of count the records between source and target for any kind of dimension you want to measure, and do a straight up comparison between the two, which is pretty expensive. And then independently perform those transformations as you're doing that DA. It's based or don't do it in the volume that you need to do. Cool. So yeah, one of the things we found, measuring data quality, very expensive, costs a lot of dollars, some cheddar, some bucks, some bread, because you got to go through, and often, and especially when comparing between sets, you're constantly running scans on those two data stores, constantly getting values, comparing them together, processing the differences, fixing some data, running it again, fixing some data, running it again, hopefully going back and fixing whatever caused the root problem in the first place. That's inexpensive, and I have not yet found a way to get around that. Like, if you've got a data quality problem, you've just gotten yourself into the hell of having to do this repeatedly. Hopefully you get to a data maturity platform where you can slow down and kind of taper off the time between these large scale whole platform profiles, which is what most of the tools that work in this space call them. They call them a data profile of, like, we're going to profile all your data. We're going to compare it to some other data. We're going to tell you what's wrong. And then you got to go through, or where they don't match up. And then we're going to go through and fix them.
Are you going to talk about some of the tools that you have or that you've used or looked at?
We have looked, well, we've looked at a couple of things. We bought into Informatica, and it crashed and burned. And then we bought into the next version of Informatica, and I didn't get it. I didn't look into that at all. They are, we're not really using it for the profiling purposes, to my knowledge. Most of what we've done in our organization is teams have built their own. So we had a couple of different teams that just built their own data comparison tools, so they could go look at a source database and look at a target database, pull up a subset of those data, compare those together, try and find problems within those, and work on driving towards solutions. We have another team actually that did great work. They got a tool called DBT, which does a lot of data transformation and can add testing actually into your transformation pipeline directly. So they not only like built a bunch of data quality directly into the pipeline, but they also built in a dashboard to like view the results of that data pipeline testing. So they get real time or near real time like results on what their data quality is, which was fantastic. I couldn't find a link to their website to show like the dashboard. Yeah, it's probably a company. DBT. It mostly, I have not done a ton with it. They kind of picked it up and ran with it. It looks like it's mostly works on a SQL or very SQL-like data structure or data language to like define what you want to transform and how you want your tests to work, and that looks great.
Do you use different strategies if you're dealing with data that is being batch processed versus streamed?
Not usually. Usually when the difference between a batch process and in the QA process, yes. When you get to the point of data profiling and looking at data quality across the data that's there, you kind of pick a point in time where you assume, for one reason or another, that the data on both sets is pretty much the same. Like all your streaming is completed, or your batches just dropped on there and been processed, and that's when you can do a data comparison between the two. But from a profiling standpoint of like being able to analyze what the data is between those two data sets, batch versus streaming is kind of academic. Now once you find a data problem, then you have different routes of investigating where that problem came from, depending on if it's batched or streaming. But yeah, for the actual measuring of the data quality itself, like the batched or streaming doesn't really matter. That's what I found.
Yeah, let's talk to that.
So what root causes did you find? What root causes did you come up with for poor data quality?
It's like I paid you $5 to stand here and give you my next prompt. What we found led us into what into some better practice thoughts. So what we really found was the problems were data streaming through systems. We, at some point in the near past, we built some Amazon pipelines to move data around, and they were leaky. Data just leaked out of them left and right. But if you test in small scale, all that it was getting there. So it wasn't until you actually hit production level data, or hit just production level weirdness, that data would go missing. And then data would, as time moved on, data services started connecting to each other. So then you had a compounded problem of, data that went up to one service was missing some data, and then another service copied that data from that first service, and now it's missing data, but also missing extra data because it might have lost some data in that transmission too. You just had a whole slew of leaky pipelines that were dropping data left and right. And for one reason or another, the QA at the time that was checking the pipelines and checking that when that software was developed, they didn't find these issues. It wasn't until we would get into production and find out hey, we have an API we serve out to external customers, and they then turn that data around and show it to our real customers. Our real customers would say, hey, our data that we know we gave you isn't showing up in this external feed you got from, that we're getting this extra, massage data from these other guys. Oh, how's that happen? So, long loop of 5 leaps of data going around, and somewhere in that 5 leaps of data, the data goes missing. And no one really, everybody goes, I don't know where that's coming from. What's going on? So that's when they really started digging in and doing these data profiles of, one thing was identifying a source of truth. We just kind of forcibly said, look, this is the database we need to trust. It might not be the first database that gets the data, but it's the data we're going to decide is the most trustworthy. We put the most effort into making that data trustworthy, and everything outside of that is downstream and could be missing. So I think that was actually a smart idea. It also helped with one of the other problems we had was some of the reports we give to our customers were not matching up between the different reports. And it turns out one of our teams that had been programming those reports didn't understand the requirements, or didn't get the right requirements, and was providing the wrong data to a calculation service, and therefore getting the wrong data back. So that was the same thing as we said, look, we know this source of truth works, and this source of truth also contains copies, the calculated data correctly. Use that as your gold standard when you're doing data comparisons and when you're QAing these reports to go out to customers and changes. So I thought identifying the source of truth, that turned out to be a really useful thing for us. I should have put that on the slide. I didn't think about it. Some of the other problems we noticed were caused by, as I said before, moving partial data sets. We said, we don't want invalid data from this database when we move it over to this other database. And then sure enough, 2 years later, now we want those invalid test events. We want that invalid data over in this other database. It's a bug that you didn't have that invalid data going over that other database. No, it was a requirement 2 years ago not to move that. Well, now it's a bug because now we want it. So move the whole data set. Don't move partial data sets. You're just going to get yourself into trouble. And I think honestly, I think that's why ELT has started to extract, load, and transform pattern for data moving has started to replace extract, load, or extract, transform, and load a lot. Is if you just move the whole database, then do the transformations and the sorting on it, you're much better off. You at least have a raw layer of your data you can look at, and you can validate that the data moved correctly before you started doing anything with it. Otherwise, you're kind of trying to QA 2 things at once, both the data move and the transformations. Have a data dictionary and know what your data means. Know where it comes, what form it should take, know what your character limits are, know what your precision on your numbers are. Is it an integer? Is it a float? All that jazz. It's real low level stuff, really important. That'll trip you up more if you just make one mistake on that than anything else. Make tools. Like I said, our teams just made some tools to push data around between services. I got nothing against buying a tool and the buy versus build. It was a continual conversation everywhere we work. I find most of the data tools that I've looked at that you can buy still require a high level of expertise in what the data is doing and how the data is structured in your own business for you to set it up. And that's often not calculated into the buy versus build process. You almost have to build it inside the tool to make stuff work. But whatever you're comfortable with, still get tools working so you can do these data comparisons, because data profiling is unfortunately one of the few ways you can actually do a real large scale data validation. Track your defects. Like, we were fortunate enough that we could go in and find defects and problems that they had. And that led us down the pathway of understanding like where are we coming into problems. So since then we've rigorously or been a lot more rigorous about tracking, like when is a data defect coming in, what is the cause of that, and then doing our best to make sure not just the data is fixed, but also the underlying problems that cause that data to be broken get fixed as well. And then data stewardship and understanding your data. I think this is a huge part of it. In fact, so big, I threw a different slide on here. Understanding your data. So many of our problems, when you dug in, when you did the 5 whys and you dug down into the problems of the data, it was caused by, well, the people working on this data didn't care or didn't want to understand, or just didn't understand what the data was for. They were moving data. You got a table of data. I want to move it to this database. I can let me write some SQL on that. And without deeply understanding what is the data, where does it come from? Where is your data source? What is the real life thing it's supposed to represent? Where is it going to? Who is consuming your data? What do they want to see out of that? How is it being transformed in your service and a little bit beyond your service that you're working on? And then what does it mean? It's not just numbers. None of these data is numbers. They all mean something. They all have some value to them that for the business and for your customers that you need to pay attention to, because if you're ignorant of that, you're missing a bug. You're missing a problem that you would have seen, because you would have been like, hey, that's weird. Standard error should never be above 5. Why is that 3,000? Well, if it's just a number, who cares? But go ahead. Question?
Realize the data is not quality data.
The boss that gave me thought data was not quality data because people kept calling and saying your data is not quality. Customers kept calling and saying your data is not quality. Like we, for better or worse, work with some sophisticated data people, large school districts that hire psychometricians and data analysts and to go in and crawl through that data. We're living in an era of big data, and that applies to education more than almost anything. Like they want to see numbers on how kids are learning. They are crawling through that data day in and day out and really analyzing it. Not every school district, but enough of them that they go, I got 2 reports here from you. This says Johnny scored a 27. This one sure shows Johnny scored a 26.4. What happened to Johnny? Like, I don't know. Let me go look. Or worse, like I said, this report's got Susan. This report, Susan's missing from this class. What happened to Susan? Where's Susan go? That kind of thing. And it's I think partially it's just the nature of our business, but partially also just, we kind of got rested on our laurels and made a bunch of data made a bunch of software really quick and didn't really grasp how it was impacting data quality. And we neglected these things. Like if we had teams, if we had engineers that really started to stick to it and understood where their data was coming from, where it was going through to, what it meant, not just Well, the story says transform it like this. I'm going to transform it like this. Understand what that transformation means. Understand why it's going through that. I think we would have had much better, higher quality software. Question.
Do you to proactively run those queries before shift? So rather than them coming back to you saying you have error, they work with you before they accept it.
We are getting better at that. With newer reports and newer data exposure that we have for the clients, we are certainly showing them stuff. A lot of our problems actually came from legacy old stuff. Stuff that, you know, the team that was modifying it and making changes to it was 4 teams away from the original team that wrote it. They had lost all their legacy knowledge, all of their, you know, the expert in the field. They were just, here's a bunch of Java code. My job is to add this extra field or change it in, you know, change from one endpoint to a different endpoint that we're doing calculations on. And didn't understand what that calculation was for, didn't understand what that calculation meant. And they went in there and just made the changes and said, it looks great. And the whole team agreed to that. Even the QA said, looks great. It's making the calculation we think it should make. And it was just the wrong calculation. So yeah, we, as part of this effort, we've definitely gone more to the customer and building more agile processes to get them on board and talk to them ahead of time and show them things first and say, hey, does this look right? Anything else? Any questions? Questions online? Seth.
Trying to add like automation or just some basic testing and just getting the ball rolling with data quality. What is some low-hanging fruit or easy things people can do to get started in adding this into their
the question is, what are some low-hanging fruit for adding stuff in for data quality? I would say go with kind of the measures that I've talked about. Like find something you can measure. I think set completeness is a really important one, especially if you're copying and transforming data across, you know, data stores. Just counting that you got the same records in table A that you got in table B in the other database goes a long way. And then dig in and do your start doing more complicated things like validating that the data is transformed correctly. If it's going through any kind of calculations, check that your data types and your data and your naming is the same between those two. It's kind of rote and routine, but it gets you where you need to go. Moss.
There are a couple comments online. Phil said, "Don't call it DQ because it sounds like Dairy Queen." and Joe suggested that what is quality data sounds like a good PNSQC talk.
That does. That sounds great, Joe. You get right on that.
And Joe also asked, how do the nulls get in there in the first place? Are we missing some checks and balances?
It depends. I mean, data input is another great way to or great area to like analyze. I think it's without going into external databases and external sources. It is probably one of the best ways you can verify that like what you're at least getting reported from the real world is what's in your database. So if your customers are like dropping a file like CSV files on you or entering data into a web form, like finding some way to occasionally just compare like, hey, they gave us this data. Is that what actually showed up in the database? Is that working? And then also the validation of that data on top of that to make sure like, hey, if this field should never be null, why are we taking null in as a possible value instead of kicking that back? And sometimes there's reasons for that. Yeah, like I said, null could be a completely valid issue. Middle name. Almost. So middle name can be null.
No.
Yes.
Yeah, his last name is No, and he got like parking ticket balance of like $60,000 or something because everybody whose name they don't identify, they just put it as no.
That's why if I ever have a kid, their middle name's going to be drop table semicolon. Actually, semicolon drop table semicolon.
Also, Eunice agreed with your comment about how ELT extract, load, and transform is better than extract, transform, and load, just because it less chance of losing something.
Yeah.
And Joe was wondering, is there a proactive way to check your data versus reactive?
I mean, proactive, like data validation on what's coming into the system. I think that's the most proactive, and like to really keep tight restraints on what your data, what are values appropriate to any particular data field. And that again digs into like, you have to know what your data means and know what it's doing to have that.
Can you repeat your question?
How does the data come in?
How does the data?
You said Excel is one way.
I mean, how did you guys all work in QA? Presumably, how does the data come in? It comes in through like, Excel, like web forms, users clicking around, analytics data from Google. I mean, there's no end to the way data gets pulled into your system, and how much massaging happens to it once it gets into your system as well. Like for a particular service, that's why it's really important to know where your data comes from. You should know where your data is coming in for your particular service that you're working on. And I can't tell you what that is because that's different for every service there is. Sometimes it's just an API. Sometimes you're just like, hey, this service just hits this API and it gets data back, and I don't care. It's like, well, you should care. Where that API is and what it looks like. And maybe it's not going to give you the right data all the time.
Well, we also had a question from Joe. It's up there on the screen.
Joe, stop it.
My final question, you're asked/tasked to figure out our data quality issues. Where are we on that? Have we found anything actionable, or are we still working through the problem?
We are still working through the problem. We have found a lot of actionable stuff. Like I said, teams have taken kind of this analysis and started working on their own tools and doing their own comparisons to clean up the data. So they've found untold number of bugs and really been able to work to get that data clean. They're still working on it. Like I said, it becomes once you've kind of got that dirty data, which I think almost everybody has, even if you don't know it. Like once you data profiling is just a regular routine task you kind of need to do for data quality, and that's a lot of what I hate. That I really hate that. I really want to be like, look, just QA your service right, and no bad data will ever show up in your databases, and you're done. But the reality is that's not true. Like the vast majority of the industry says, you got to profile your data every now and again. You got to do data checks. You got to at least have a baseline of knowing what your data looks like. And on whatever data dimensions you want to measure, the ones I presented here are just a selection. There are a ton of data dimensions. Pick ones that work for you. Pick ones that highlight the data problems you have and work with those.
What are some data dimensions that you chose to work with?
We chose like set completeness when working between like two data sets. What uniqueness constraints, completeness constraints within a data set to see how many fields were null, not accuracy, precision. Some of these terms are loosey-goosey depending on what you're when I was writing it. Precision to make sure like transformations were occurring correctly, data was showing up with the correct like rounded values in databases. And again, most of our problems were data fidelity problems of like copying data from one database into another and transforming in between. We would either lose data or the data would be, have a transformations misapplied and come up with kind of like the wrong data on the other end.
The comment that it's easier to copy from database, start the it's not always possible or even allowed. Obviously, data mart and data warehouses are created by extracting data based on regulatory requirements and other privacy and other issues. You can't just extract the whole database and do it just because it's more convenient for database analysts.
Yeah, no, I like the statement was that you can't always extract an entire data set over to do like an ELT and just copy it all over. Yeah, not that I in reality always conflicts best practice. Sometimes you got to deal with what's that? I don't know what country you're living in, but this is not best practice.
Wait, there's a problem with that statement. If there's a privacy requirement, a statutory requirement that forbid you to copy the whole data.
Yeah. No, I mean, there's best practice. Their best practice is an ideal. Like, what would be best for the data quality? And then there's, well, you have to work within the constraints of your customer and your business. If the customer and business say you can't move all this data because you don't have access to it for security reasons, that's constraint you've got to work around. So clearly, you just work with that.
Well, I'm glad you agree because some of that would be legal requirements.
Yeah, some are legal requirements. But in like a pie in the sky, no legal requirements, you'd be like, well, why wouldn't I just copy all this data over here and then I can do whatever I want with it?
From this that you're able to extract into, be able to get into like your CI/CD pipeline. So each time there's a commit or anything, you're validating.
Yeah, a lot of the team I was talking about that worked with the tool called CDT, they built a lot of that into their CDT or into their CI/CD pipeline. So deployments go through a testing phase, which comes up with a CI/CD with data quality measures that they actually include in that pipeline, and if it has degraded too much, it'll fail the builds. Yeah, that's another weird thing about data quality is like once you start like digging into it and understanding you have to like do profiling and checking out data, suddenly like 100% is not a goal. You just kind of be like, well, we want to keep it above 95 and then we're cool. Which is really hard for me to swallow. But again, that's the industry. I mean, and that's all the way from government to banks that will accept some of those tolerances.
Yeah. So I have a question about all these tools that you're using and how much that you automated the whole like data quality analysis. So can you elaborate that?
Are there tools that we're using and how much have we automated the data analysis processes is the question. We've built some of our own tools. We've adopted some of tools that like DBT is the primary one we've adopted. Otherwise, we've built JavaScript, SQL, Frankensteins to pull data from different places and compare them together. We are driving towards automation on some of those. A lot of this work came in as do data quality, get it working right away. And teams resist. Teams just go start working on the problem and don't work on the like, well, then how are you can you automate that? Can you do that every day now? So they're working towards that goal as we speak, getting it much more regular. And I think that is where you have to go initially. Like I said, data profiling is a thing you kind of have to do. So the more you can have that just be a routine part of business, like with test automation and just like running every month or every, whatever schedule, whatever your cadence your company's comfortable with.
And also, how much is that kind of reusability of these tools? So, is your experience like you pretty much can reuse 80%, 90% of the tool, or?
I think you can. It gets into the weeds. Like anytime you're dealing with data, you have to write specific queries for your data.
Okay.
Like a lot of the tools like Informatica or Talon, they promise you the ability to just like, well, I'll just connect to your database and tell you like, here's the tables you have. We'll just compare them right away. And they probably do a lot of that. But if you want to get down to the weeds, you still have to do work to explain to the tool, here's my data, here's the tool tables, here's where I want to compare it to, here's what these fields should look like. Which is not terribly different than what you're going to do with writing a bunch of SQL statements. I prefer SQL because I speak SQL, but that's just me.
Jim also had a question up there on the comments. One thing he ran into in a past job, if data is transformed and moved from source to target and the source is not really high data quality, like old or legacy data from a mainframe, then you really have two data quality challenges to deal with, not one. Do you want to comment on that?
Yeah, that's kind of exactly what we ran into in some ways with our data moving from place to place to place. Is a lot of our data problems we found weren't caused by the most recent jump, they were caused by the jump 2 steps back. It's where you got to dig into, like, understand, like, what is is the intrinsic data quality of your source database compromised, or do you have a data fidelity problem of, where you're losing data or compromising data qualities you're copying between those two. So, like, it sounds like in your case, like, there should have been a data analysis done on the source database to make sure it was high quality data in the first place before you started doing all this copying of it over. Because you can never get, never get higher fidelity in a copy than you had in your source. It's
It was just 40-year-old data.
Unless you're making it up, yeah.
Yeah.
And Bilal asked, do you recommend any books or articles or papers on data quality and data stewardship other than the Stanford model?
No, but I should. It's a good idea. And even that Stanford data model, I question. We're working on implementing it. It's very not agile. It's very, look, guys, you're gonna be mature in about 5 years, and then things will go. We're great. I'm a much more agile, or I'm a big proponent of agile. Like, just get it working, figure it out, and continual improvement. So I'll keep an eye out and look and see if I can find a good source on that.
I have a question. How do you, if you have a steward that was paying attention to, like, for example, the atronymity, like we had a system for a long time, and at one point they asked for be able to mark a patient as active or inactive, and so we created that as deleted or not deleted, and then later they wanted it to be called a person that was really, like, inactive, like hasn't come in for a year, but they're not deleted. And so, I mean, like you're saying, it's a legacy problem dealing with renaming things. Do you have any suggestions for, like, the person who probably named that originally was not with the company anymore? How do you pass on stewardship from one person to the next?
I think someone kind of has to suck it up and just get cozy with the data and learn it. Like, that's honestly a big part of the problems we ran into is there's not a lot of data stewards in our company. Like, even like, it's usually old salts like myself that just got to know the data over years and now are extremely knowledgeable about it and can say things, but no one else was jumping up to fill those holes. For actually solving the problem, I think it's nice to have a label to put to it to say, hey, this is a data quality issue. We need to change the name of this field, because otherwise they go like, look, that's going to take 30 hours of going through and renaming everything and testing it all. That's not worth your effort. And I can tell you it's worth your effort. Yeah, a question over there?
Oh, one more question here.
Stuff. End result is money goes in different places. And so come to find out, he's fudging a lot of stuff. And I mean, a lot of stuff. Because it's all the data he's pulling in is from silos, ETLs that have not enough resources, all those stores. So my question is, how do you keep, so in when you're coding, right, you have comments and stuff like that, people can come up behind you and they can kind of get an idea what you did. So how do you kind of prevent somebody from doing something like this, or where do you put the assumptions that people make in the data, right? Because somebody's gonna figure this all out in the end, and somebody's gonna tell the business that their money is going in the wrong place.
Yeah. So the question is, gentleman here has a works for a place where they generate a yearly report, and it turns out the guy who was in charge of that may have been fudging the data, having pulled it from a variety of sources. How do you keep track of like all the transforms and all the work that he's doing so that someone else can come in behind him and either take over or potentially even audit him? I think go ahead.
This across the world, whatever. And it's not really documented. People just kind of like, oh.
Yeah. He goes on to say it's a common thing that's just happens, and people just go with it. Decisions are made, people move on. I don't know how to fix that. I've been thinking about this for a while. Like, the problem is basically legacy, or like legacy knowledge. What's it called? Yeah, institutional knowledge. Like when the only people that know how to do this is the people that have worked here for 5 years or more, and everyone else is kind of ignorant. The standard solution that I will usually run into is like, well, they should have documented everything they did, and every time they did it, and that never works, because you will spend way more time documenting things than you would ever spend actually doing the things, and you will spend more money on the documentation than it ever is going to be worth. Though there's shades of gray in there. I don't really know a better solution. I've been trying to find a better solution of like, how do you capture institutional knowledge, because so much of it is just invisible and just like in people's heads, and it would be real hard to pull it out, and you can't just pull it out in like a run book for like, how do you generate these reports? I mean, that would be like the textbook definition is like, generate the reports like this, and then have somebody else go do it, and then compare those two together and say, I came up with different numbers. Why is the software department for your version getting $3 million more than my version?
So what I did was I said, put your assumptions in thought. Be transparent. Whether we know it's true or not, that's a different story, but at least we have something to talk.
Yeah, I think it's a great idea. Just put your assumptions in somewhere in the report. Like I tend to bury, again, I speak SQL. So if I generate a report, I will flip open a different tab on that Excel spreadsheet and just paste the query I threw down, which will often also include comments throughout the query of like, here's what I wanted to get, and here's how I was pulling it together. No one else will likely understand it. But at least it's some sort of record you can piece through and look at and go like, okay, I get where this is, what's happening there. Yeah,
Joe had a comment that if someone's fudging their data, that just compounds the problem. I don't think there's a real solution for that beyond more work to figure out what they were fudging. Or his second opinion is fudgers should be fired. I think it's like what you're saying. If you're trying to increase resolution or precision on the data after the first copy, you're just making it up at that point, right? So you can't increase precision without having some fudging,
Yeah, but even the problem with fudging is you're always increasing the precision to tell the story you want to tell. It's hard to do so in a very neutral way of just like, I'm just letting the data speak for itself, and just, because fudging requires a decision, push it one way or push it the other. And if, you usually have an opinion, and maybe even an unbiased one. Yeah, I too frowned upon fudging data. Like I am a big proponent of like, put your data together and give it to the people that need to make the decision, and don't try and make that decision for them. If you're lucky, if you work in a good place, they will want you to be part of that decision making. But still, you've got to have the right data. I'm a straight up scientist in that way. Like fudging data is the biggest crime that you can commit in science.
For I was working on a patient tracking database, and we had to put in something for gender, either male or female, and it took a long time for people to decide on what was the default. Now they have an other for that's accepted at the HL7 level. So it's you can choose other, but previously it's like you had to choose either male or female, and it was kind of like, oh, is this going to be accurate or is this going to skew things? Are most people male or most people female? It's more people in the United States are female, but yeah.
just by a smidge. Any other questions? All right. Well, thank you, everybody. I hope you enjoyed it.
Thanks everyone for showing up. I'd like to remind you that PNSQC has a call for papers is open until Monday. It closes Sunday night at midnight, I think. And so we're looking for things like abstracts. You don't have to write the whole paper. I had someone submit a whole paper today, and I told them just an abstract. It just has to be, 2 or 3 sentences that describe what the challenges that you encountered, how you addressed it, and then how you used your solution to either improve the quality of the software or discover that it doesn't work to improve the quality of software. We're okay, as Phil said, we're okay with discovering ways that it doesn't work. It's a learning experience. And then also include a bio, and you can just go to pnsqc.org, and there's a button right on the homepage to submit an abstract. And we're working on the lineup for the keynotes and the invited speakers, and we can announce that later this month. If your abstract is accepted, you get to speak at PNSQC in Portland in October, and you'll be rubbing shoulders with some international software quality professionals that will be big names and fun to talk to and network with. Anything else, Phil? Did you have anything?
I don't think so. I think just thanks for everyone for coming, and look forward to meeting you in October in person.
Talk again, Phil.
Take care, guys.
Okay.
Have a good weekend.
That was good. You did a good job. Thank you. Thanks everyone for showing up.
We have had some very low turnout. Thanks everyone for showing up, and that's the end of the presentation. Thank you, Heather. And thanks to Nick for the great presentation. And now he gets to eat his hamburger. One thing to mention is next month's meetup will be at a different location. It'll be on Beaverton Hillsdale Highway in Portland, and we'll have pizza and beer. It's Steeplejack Pizza and Beer. And that event is already posted on the PNSQC homepage. All right, thanks.